Why do we need singleton? Problems it solves. To understand why the singleton design pattern exists, we must first look at the problems that arise when multiple instances of certain objects are created unnecessarily. In software systems, not every class should be instantiated multiple times. Some components represent shared resources, global configuration, or centralized control points. Creating multiple instances of such components leads to inefficiency, inconsistency, and system instability. Problem 1. Resource waste and performance overhead. Some objects are expensive to create. Examples include configuration loaders, logging systems, database connection managers, cache systems, and messaging clients. If every part of the application creates its own instance of these objects, the system wastes memory, CPU, and network resources. Without singleton, an application might load configuration files multiple times, open multiple unnecessary connections, create duplicate caches, initialize heavy objects repeatedly. Singleton solves this by ensuring only one instance exists and is reused, improving performance and resource efficiency. Problem 2. Inconsistent state across the application. When multiple instances exist, state consistency becomes a major issue. For example, different parts of the application may read different configuration values. Logs may be written to different files. Caches may become fragmented. License or security rules may be applied inconsistently. Singleton provides a single source of truth, ensuring all components interact with the same instance and observe consistent behavior. Problem 3. Lack of centralized control. Some components must act as central coordinators. Examples include logging services, cache managers, message queue clients, security, token validators. Without singleton, each consumer may create its own version, making monitoring, configuration, and control difficult. Singleton centralizes responsibility and simplifies management. Problem 4. Connection and resource exhaustion. Creating multiple instances of components that manage limited resources, such as database connections, file handles, or network sockets, can quickly exhaust system limits. This leads to application crashes, database overload, thread starvation. Singleton limits access through a single managed instance, preventing uncontrolled resource consumption. Problem 5. Architectural chaos and tight coupling. Without singleton or DI managed lifetimes, developers often resort to static access or global variables. This causes hidden dependencies, tight coupling, poor testability, difficult maintenance. Modern singleton usage, especially through dependency injection, solves this by making dependencies explicit and controlled. Problem 6. Difficulty in testing and maintenance. Multiple uncontrolled instances make it difficult to mock shared services, track behavior across the system, maintain consistent configuration. Singleton via DI allows easy replacement with mocks or fakes, improving testability and long-term maintainability. What singleton actually solves in simple terms? Singleton solves the problem of unnecessary duplication, inconsistent shared behavior, uncontrolled access to limited resources, lack of a single authority for infrastructure services. Important clarification. Interview tip: singleton does not solve business logic problems. It is not meant for user workflows, request data, or database contexts. Its purpose is to manage shared infrastructure concerns, not application behavior. Final summary: we need singleton because some parts of a system must exist only once, be shared safely, remain consistent, control limited resources, act as centralized services when used correctly, especially with dependency injection. Singleton becomes a powerful architectural tool that improves performance, consistency, and system stability.